Hey y'all, it's Miss Johnson. Welcome back to asynchronous time and the videos that we're doing. It's January 15th. We're talking about the product rule and the quotient rule. Let's do it. The first thing I'm going to do is go over the notes that I think you have so far. These are the things that I think we can take the derivative of and the patterns we already know. And then we're going to use all of these and expand them on this work. So far we know the power rule. We've known that one for a while. The derivative of something that looks like a times x to the power of n is a times n x to the power of n minus 1. Bada bing. The constant and linear subcase of this is when we have mx plus b. The derivative is just m plus 0. So basically just m, right? It means the b goes to 0 and the mx goes to just m. The product rule, which we learned today in class, is when we take the derivative of two functions multiplied together, we don't just multiply their derivatives. We, in fact, put them into this pattern, which is the first times the derivative of the second plus the second times the derivative of the first. Let's make that look a little nicer. Fine. And then the quotient rule, if we have the derivative of two functions being divided, we don't just divide their derivatives. We do this entire big song and dance, which is the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the thing on the bottom squared. Cool. And then we know some of the trig things, and we're about to learn more of the trig things. The derivative of sine we know to be a cosine. The derivative of cosine we know to be negative sine. And then the derivative of tangent we know to be secant squared. We figured this one out in class using the quotient rule, and we're about to figure these three out in the assignment, also using the quotient rule. All right. Bada bing. The assignment has a couple practice product rule problems, and then the quotient rule problems are figuring out the rest of the trig functions. So I think they're worthwhile. Let's remember how to do these product rule questions. I've done 2 examples for myself. In this example, we want the derivative of 4x to the 8th tangent. I'm going to label this as my f. I'm going to label this as my g. Off to the side somewhere, I'm going to say f prime is 32x to the 7th, right? That's the derivative using the power rule. Over here, I'm going to say g prime is secant squared x. That's the derivative using the fact that we figured that out earlier today. And now I'm going to put these 4 facts into my pattern and just write the derivative. So I'm going to rewrite f. I'm going to write the derivative of g. I'm going to put a plus sign, remove this. Then I'm going to rewrite g and then write f prime. That is a finished answer. I'm done. If you want to stop there, be my guest. If you want to simplify a little bit and clean it up so it looks nice, this one already looks as good as it can. And then generally we put the polynomial stuff before the trig functions if you really want to. But either of these are right. And we're doing good. The next example I want to do has a fraction in the exponent, but the power rule does not care whether this is a fraction or a decimal or a negative number or an irrational number or whatever. We still just get to follow the same power rule as always. Here is the f. Here's my g. Over to the bottom, I'm going to figure out the derivative of both of these so that I can just read it off and put it into my pattern instead of thinking, because that takes a long time. All right, the derivative of cosine is negative sine. I do the easy ones first because that's how I roll. The power rule says this one is write the coefficient, multiply times the exponent, and then knock the exponent down by 1. Here's 7/3 minus 1. I'm going to write it as minus 3/3. Then I'm going to simplify a bit and say 9 divided by 3 is 3. 3 times 7 is 21. X to the 4/3. All right, I've got my 2 functions. I've got my 2 derivatives. My power rule up here says that I rewrite this, write rewrite the first, write the derivative of the second, plus rewrite the second times the derivative of the first. Again, that's a finished problem. We're done. I'm a little bit pedantic, so I'm going to simplify a bit. Negative comes out front. Polynomial stuff goes before trig. And then there's no negatives here, so it's plus. And that looks casually nicer, in case I had to use it for something later. But on all of these problems, they look like this. And then our answer should look like this. And what you need is you have the f, you have the g, you need to calculate the g prime, you need to calculate the f prime before you put it in this pattern. All right, and then quotient rule, we did this for, oh no. Nice. We did this class for tangent. I'm going to do it for cosecant. And then I want you to write along as we do this. And then it'll be up to you to try cotangent and regular secant. All right, let's do it. I've also got my list of, where's this? I've got my list of identities here. I'll put this over here just so we can have them. Nope, go away. Just so we can have them on the note sheet. Okay, for example, we want the derivative of cosecant. That is going to be the same as the derivative of 1 divided by sine. Right, that's something we read over here. And now I know the derivative of 1, I know the derivative of sine, and these two things are divided. So I'm good to go. I'm ready to take the derivative. On my quotient rule, this is g, this is f. I know off to the side I'll need the derivative of both. The derivative of 1 is 0, and the derivative of sine is cosine. And now we just get to put these 4 things into this pattern. We do low times the derivative of the top minus high times the derivative of the bottom. And then we take the bottom and we square it. All right, so this one was just the quotient rule pattern. We could stop there, but that doesn't really mean anything to me, and I want the derivative of cosecant to like mean something so I can fill it on my note sheet. Sine times 0 is 0. 1 times cosine is cosine. So the top becomes negative cosine. And I'm going to write the bottom like sine times sine. The reason I'm going to do that, you ready for this? Cosine divided by sine is cotangent. And 1 over sine is cosecant. I'll keep the negative. I'll rewrite all the yellow stuff as cotangent of x, and I'll rewrite all of the pink stuff as cosecant of x. And this, let me make it green. This is the derivative of cosecant. Nice. So I'm going to scroll down here to my notes. I'm going to say, boom, this is negative. Usually people say cosecant, cotangent. I'm not really sure why, but that's what you'll read in most books. Okay, so we're one step closer to having all the trig functions and knowing their derivatives. It's your job to figure out these two and to fill in this one. And that is the assignment, y'all. If you need more help, please email me or come to office hours. I will post this note sheet as well as the notes we took in class on your Schoology page now. All right, see y'all on Tuesday. Stop sharing.